Hi guys, welcome back. The first review was all just basically me reteaching the motion problems, so you got a second round of that. Okay, the rest of the review is everything else that's on your quiz, okay? So, first one, derivative of an inverse. Okay, if you think you know how to do it, then hit pause and try this problem on your own. Hopefully you can do it. All right, assuming you hit pause and did it on your own, whenever I see these two symbols together, derivative and inverse, I think flip, flip. I know it's not formal, but that works for me. Flip, flip. Every time I see one of those, I write f of x and f inverse. I know that this is the x coordinate on my inverse, and I know that the question is really what is the slope or the derivative there. This is what I'm looking for. Well, if it's an x on the inverse, then it's really a y on the original. I need to find the x that goes with it and find the slope at that value, and that won't be my answer. I'll still have to flip it. Okay? So first, what is the x coordinate that goes with this y? Well, if y is 2, that means this guy right here is 2. And I need to solve for x because it's the x that I'm missing. So to get rid of the cube root, cube both sides. If I cube both sides, 2 cubed is 8, and the cube and cube root undo each other. Subtract 1, you get 7. Well, this is a little less than pleasant. Divide by 3, and we get 7/3. So that's the x coordinate. Lovely. Now I need to find the slope there. Well, how do I find the slope at 7/3? I have to find the derivative. Okay, so now I need to find the derivative and plug in 7/3. All of this was just me trying to find the x coordinate that I was going to use. Okay, next up we have inverse trig. You have to know these two formulas, so let me go over memorizing those. Your inverse sine formula and your inverse tangent formula. So remember, they both have a 1, and a u squared, and a du. A 1, a u squared, and a du. Inverse sine. Sine starts with an s, and s is for square root and subtract. That's your inverse sine formula. Tangent, inverse tangent, starts with a t, and the t looks like a plus. Okay, so you do have to memorize those two formulas. Now I'll show you how to apply them again in case you've forgotten. Okay, to apply these formulas, you need to know what is your u, what is your du, and you can even figure out what u squared is in advance. Okay, so for each problem, first one, inverse sine. My u is negative 2x cubed. My du is negative 6x squared. So now applying the formula, the derivative will be 1 over the square root of 1 minus, take your u and square it. When you do that, do it in your head. Negative 2x cubed times another negative 2x cubed, and you get 4x to the 6th. Don't forget times du, and this is your du. I can put it out here, but I usually just put it right up on the top. Negative 6x squared. Okay, that's it. Easy. Doesn't get any harder than that. Simple. Okay, inverse tangent. Well, what do you do with this 3 if there's a number in front? Well, what would you do with the 3 if I asked you for the derivative of this? No big deal. You just bring the 3 down. The derivative of that is 3 cosine x. So same thing. If you have a coefficient, just bring it down. It'll end up in the numerator of your fraction, okay? So let's do inverse tangent. The derivative would be, oops, I messed up. Let me find my u and my du first. U is 4x to the 5th. So du is 20x to the 4th. Applying my formula, the derivative would be bring down the 3. And then I have 1 over 1 plus u squared. Square that. You'd get 4x to the 5th times another 4x to the 5th, which is 16x to the 10th. Times du, which is 20x to the 4th. And then my final answer would therefore have a 60x to the 4th in the numerator, and that's it. Easy, no big deal. Okay? All right, moving on to the next type of problem. Okay, guys, so for the next one, we're going to do the equation of a tangent, which you know and love. I told you it would never go away. So we need two things. We need point, we need slope. So to get the slope, we need the derivative. And in this case, to get the derivative, we'll need implicit differentiation because we have x's and y's all mixed together. Okay, so that's how you recognize implicit differentiation. Remember, when you do implicit differentiation, if you do the derivative of an x, you do it like normal. But when you do the derivative of a y, you have to tack on a dy dx. And this problem here also, be warned, this right here is a big neon flashing light, okay? That has two variables, an x and a y, so it's a product rule. And when you split it up, make sure you keep the negative with the 3x squared. All right, so here we go. The derivative of y cubed is 3y squared dy dx. The derivative of this is my product rule. So I have a negative 3x squared and a y. Do my two derivatives, negative 6x, and the derivative of a y is 1 dy dx. Crisscross, and my derivative is negative 3x squared dy dx and minus 6xy. Do the derivative of negative 11, which is 0, and on the right side, derivative of 0 is also 0. Make sure you do the derivative of both sides of the equation. Now you got to get the dy dx by itself. So move the 6xy to the other side, which will make it a positive 6xy. We're going to move that one over. Okay. And you could kind of do some of these steps in your head. So move the 6xy over. Next, factor out the dy dx. And then divide by that big bunch of junk to get the dy dx by itself. And that's your derivative. Dy dx equals 6xy over 3y squared minus 3x squared. Now, you may notice that I could factor out a 3 in the denominator, and then I could cancel the 6 and the 3. So you can do that if you want to, but for this problem, we have to evaluate the derivative at this point in order to get the slope. So since we're not going to be leaving the answer like this, and I'm going to instead use this derivative to get the slope, it's maybe not worth the risk of simplifying it incorrectly. Okay, so now I'm going to plug in the 2 and the negative 1. So the derivative evaluated at 2, negative 1. I'm going to plug in an x of 2 and a y of negative 1. X is 2, y is negative 1. In the denominator, 3 times negative 1 squared minus 3 times 2 squared. 3 times 4, that'd be 12. And you don't even have to show any work for this. So I have a negative 12 over a negative 9. Simplified, that's a slope of 4/3. So put it all together, point slope form. Y minus y1 equals m times x minus x1. And leave it like that. You don't have to make it any fancier than that. Okay? So, implicit differentiation. When you do the derivative of a y, make sure you tack on a dy dx. It's actually a chain rule. Okay? One more, I think. Let's see what we got for the next one. Yes, definitely. Okay. Find all horizontal and vertical tangents. And we're not gonna find coordinates. We're just gonna find where they happen. So, horizontal and vertical tangents. Horizontal tangents are when the derivative is 0, which will mean the numerator is 0. Vertical tangents are when the derivative is undefined, which will be when the denominator of the derivative is 0. All right, so we've got x's and y's. So implicit differentiation. Here we go. Derivative of 2x squared is 4x. Derivative of 4y squared is 8y dy dx. Derivative of negative 8x is a negative 8. Derivative of 24y is 24 dy dx. Derivative of 6 is 0, and derivative of 0 is 0. Okay? By the way, with implicit differentiation, if you forget just one of these dy dx's, it messes up your complete problem. Okay? So be careful. Alrighty, so now get the dy dx by itself. Let me fix this. All right, so anything that has a dy dx will stay on the left. Anything that doesn't have a dy dx moves to the right. Factor. And now divide to get the dy dx by itself. Again, this is one we could factor this. I could factor a 4 in the numerator, and I can factor out an 8 in the denominator. But since this is not my final answer, I didn't just say what is the derivative. Instead, we're using the derivative to find an answer. Since we're going to be using it for something else, it doesn't really matter if you simplify this or not, okay? So, horizontal tangent. Make sure you don't mix these up. To get a horizontal tangent is when the derivative is 0. And on a free response question on the AP exam, you have to write that. Well, this derivative will equal 0 when the numerator is 0. So when will negative 4x plus 8 equal 0? Solve that, and you get when x equals 2. So that's a horizontal tangent. Don't mix them up. Okay, that's my horizontal tangent. Vertical tangent. That's when the derivative is undefined. Well, the derivative is undefined when the denominator is 0. Okay, if you solve that, you get when y is negative 3. So that's where you have your vertical tangent. Okay, and you can leave it like that. You don't have to find the coordinates like we did in some of the other ones. Just leave it like that. That's fine. You get the main idea. Okay, my main goal for this quiz is just to make sure you understand the new concepts. I'm not trying to make it super duper computationally difficult. Okay, all right, so let's see, is there more or did I get it all? I can't remember. Ah, yes. What does that sucker mean right there? Those 2's, hopefully remember that means second derivative. You'll have one of these on your test too. To find the second derivative, I have to first find the first derivative. So here I go, first derivative, implicit differentiation. Derivative of 2x cubed is 6x squared. Derivative of 3y squared is negative 6y dy dx. Derivative of a 7 is 0. Get the dy dx by itself. Subtract 6x squared. Divide and we get dy dx is equal to negative 6x squared over negative 6y. The negatives cancel, so I get x squared over y. Excuse me. So that is the first derivative. But we want the second derivative. The only glitch about second derivative with implicit differentiation is your second derivative will have a first derivative in it. And therefore, you'll have to replace the first derivative with this. You'll see when we get there. Here we go. So now we're going to do the second derivative. All right, that means the derivative of this. Well, that's a quotient rule because it's 2 variables. If the top or the bottom was just a number, you would not need a quotient rule. All right, so here we go. Second derivative. And by the way, when I write second derivative, I'm literally doing the derivative of this side is what I wrote in red, and now I'm doing the derivative of this side, quotient rule. Okay, low, which is y, d high, 2x, minus high, x squared, d low, dy dx. Draw the line and square below. Okay? Take that dy dx and replace it with what dy dx equaled. So I have a 2xy minus an x squared times x squared over y, all over y squared. Smush this together, multiply across, it'll be an x to the 4th over y. So I have 2xy minus x to the 4th over y squared. And then finally, don't leave fractions within fractions, and hopefully you're really good at fixing this now. So to get rid of the fraction within fraction, multiply by the problem, which is y. So we're going to multiply by y, a y, and a y. So we get 2xy squared. These y's cancel. You get an x to the 4th. And on the bottom, I have a y cubed. Okay, now that's it for this one. You may remember, though, from your homework, you had a few where they took the original equation and substituted that in the answer as well. Well, I don't see any way that I could get a 2x cubed minus a 3y squared in my answer, so I can't do that. And don't need to expect that on the test either. It'll be like this, nice and straightforward, okay? All right, so good luck, guys. I posted a review, and now you have like 3 reviews, And I'm really hoping you all get hundreds on your next test and your last test of the quarter. Bye.